Hello, welcome everybody on second online GDG3 City meetup. This time we'll talk about Flutter and a little bit about GitHub. We have three amazing speakers today. Kamil, Martin, and Dominic will share their talks with you. The first one is from Kamil. It's about async way of Flutter. We will give him a chance to speak in a moment. Sorry, I need to turn down my notifications. Sorry. All right. And we will have some time for questions after his presentation. And after each presentation, we'll have some time for questions. Please type questions on our YouTube channel. And after those three presentations, we'll have a small contest on Kahoot with some prizes sponsored by Schibsted. So please welcome Kamil. Hi.
Hello. Hello, everyone. Today, I will be talking about the async way of Flutter, and my name is Kamil Rykowski. Well, that would be mostly about the async way of Dart, as that's the programming language of Flutter, but we'll see this in a moment.
Kamil, the stream is yours.
All right, so about me, I'm working as a developer for like 10 years. For now, I've been working in a backend, front-end, DevOps, basically all the roles which are technical. And currently I'm working as a software engineer in a local startup, Lab for Life, where we are using Flutter to deliver mobile application which will work on user habits, and it will increase users' health. I'm a cross-platform freak. I've been starting with the tools, with the technologies like Cordova, PhoneGap, and then jumping into the Xamarin, React Native, and then my current love is Flutter, which I work non-commercially for like 2 years now. After hours, I'm indie mobile game developer, and I'm trying to build an online multiplayer game for Android and iOS devices, which is in a post-apocalyptic world. It's still not yet released, so give me a year or two. Other than that, I'm a blogger, open sourcer, speaker. Basically, I like to share the knowledge and give something back to the community. So let's start with the main part of the presentation. And first thing first, let's make it clear that Dart itself is a single-threaded language. So it has a single-threaded execution model. So what does it mean for us as developers, as consumers who builds applications, is the fact that it can do only one thing at a time. There is no module like a multi-threading, which we can spawn multiple threads and perform some operations using multiple threads to speed it up, which leads us to the no interruptions, because if we have only a single thread, no other thread can interrupt us, which is quite good because we have no deadlocks, no race conditions, because there is no interruption. So we have a single thread, and that's basically fine. And of course, same rules applies to the Flutter itself, because Flutter is just a framework, and working on a mobile app, we are writing the code in Dart, not in Flutter. So Flutter itself could be also treated as a single-threaded execution. And here I posted a simple code which demonstrates the synchronous way of Dart, where we have some print start main, then we are printing sorted list of numbers, and we are printing end main. If you will look into this function, the random sort, Well, it's not efficient. It's simply shuffling the list till it's sorted, and then it returns it to the main. But what does it mean for the Dart? As it's single-threaded, there is no way that any code would be executed between start main and end main, except this random sorting. There is no shared memory for other threads. But still, we have the async code. And async code, the basic of it is that it starts now and finishes in the future. Well, in some future, we don't know yet when it will finish. And the most important part of async code is that it do not block rest of our code. So if we are performing some operation in async way, we are not blocking the thread itself. So for example, the UI is still responsive when we are performing some async code and so on. And mostly related to the I/O operations, as you probably know, like the network requests, where we are querying our REST API or GraphQL API or whatever is at the network. So it doesn't mean what kind of API. It's just about the network requests, reading local files and writing local files. That's also an I/O operation, which is done in an async way. And of course, many more. So the async code is not only related to the I/O operations. That's the most basic stuff, most stuff which we'll use in our applications, but basically any code can be run in an async way. And if we are talking about the async way, then we should understand how Dart performs it, because it has only a single thread. It can perform only one operation at a time. So what's the thing behind this async operations? Dart is running an event loop. So that's a similar thing like in a JavaScript, for example, where we have an infinite loop which processes our app events. And okay, so infinite loop which processes an event. And what is an event? It's like user gesture, like swiping or tapping our screen when we are developing mobile application, but also fetching HTTP responses, like we are querying our API and we are responded with data from the API. That's the same kind of event for the event loop. Also, we have timers, like do this operation like every 5 seconds. That's also some kind of event. And events on the event loop are stored in 2 FIFO queues. So we have two. The first one is a microtask. It has a high priority, and the other one is an event queue. It has it's a normal priority. So that's the basic queue which we're gonna use in our mobile applications. We'll talk about these queues in a moment. And here we have some dummy mock implementation of the event loop. It's performing infinitely, so we have a while true. The first thing, we are fetching the microtask from the queue. If there is any microtask, we are running it. And then we are iterating once again. And when there is no microtask, we are going into the event queue and asking if there are any events to run. If so, then we are running the event. Other than that, we are doing nothing and performing the iteration once more, because there could be new microtasks or new events in the meantime. And how to work with this event loop? Because writing synchronous code is straightforward. Everyone knows how to do it, but how to operate with this event loop? Dart exposes a simple interface to work with it called futures. And futures are used to run some code asynchronously, but not in parallel. So keep in mind, remember the fact that when you are running a future, it's not running in parallel to your main execution flow. It's run asynchronously. So it doesn't mean that two things happen at once. Only one thing can happen. The future is executed on the event queue, so we are using the event loop and the event queue, which could lead us to the fact that future is simply an event. And it has 3 states. It's the first state is new and completed when we create a new future. There is a successful state when the future have completed with a value, so no errors happen during the execution. And we have a fail state, so the future have completed, but with error during it. And how it works from the code perspective. First thing is that we need to import the Dart async module. And here in line 6, you can see that we are creating an instance of future class. So we are creating a future which as an argument accepts a callable. And this callable would be, well, in simple words, it would be transported into the event loop and executed there. So what does it mean is that if we run this code, we'll have such prints on the console. So the first one is the start main, then we have an end main, and after that we have future is now. And why is that? Is that Dart will execute the synchronous code first. So it's gonna execute the start main, then it will create some future and put the code on the event loop, but it's not gonna to run the internal callback. That's gonna be run through the event loop. And after that, we are printing the end main. Then we are finishing our execution because the main has finished. So the event loop can run all the events which popped up during the execution, which is this particular future. There's also then, because the futures exposes some API which we can use to work with. And the most basic one is a function method, then. It's used to register some callback for the future to run some code when it's over. So in this example, we are printing the start main, we are creating again some future. Then in line 10, we are creating another future. And in line 14, we are calling the future.then. And we are creating the message of it. So what's the output of it is that, well, the first thing is quite easy because we have a start main and end main. That's asynchronous. Then we have a future is now. And after that, we have an old man. And why is that? Why do we have an old man before where am I? That's because the then is not put onto the event loop. It's run synchronously after the future has resolved. We are returning the old man, and after that, it calls all the functions which has registered for the future completion. And the future on the line 10 is putting another event on the event loop, so it would be executed at last. There is also some API about catching errors and when complete, which, to be honest, I'm not using it because it's error prone, which I will show on the next slide. So I will simply show you some slide that was the execution of it. It's about catching errors in our futures. So we are printing the future is now on line 7, and we have 3 functions. We have a then, catch error, and when complete. And you can see that old man 1 is not printed on the console. And why is that? Because on the line 8, we are throwing exception. So we are finishing our future with error. So it didn't succeed. So then it's not called. Instead, the catch error is called, and then when complete is called. When complete is a analogy to the try catch finally. So it's always executed. And I said that I'm not using this syntax of the catch error and when complete. And why is that? Here on this slide, you can see a code from the official library for handling cloud functions in Flutter, developed by Google. And there is some problem with it, because we can see that there is a try catch block, and within it we are calling some code, and we want to catch some errors. Yeah, that's fine because we do this on a daily basis. But here you can notice that there is used then. So it probably means that this particular code is on future. It's run on an event loop. So it won't be run synchronously. So this try catch won't work. In order to catch an error, you would need to provide a catch error function. And what happens when you run such code? Well, the error won't be catched. That's it. So that's why I don't like this particular syntax, especially that Dart provides us some syntax sugar for working with the futures, which is called async await. It's included in probably most of the programming languages nowadays. So how does it work? Is that the code on the left do the same thing that code on the right. So we are, instead of putting our code in then function, like future is now, then, end main, and by, we are using the await keyword. So we are telling the execution flow, await for this future, and then you can execute the remaining part of the main. That's just a syntax sugar. So it's you can treat it like both of these do the same thing. And in order to use the await keyword, you need to mark your function with the async. So on the line 1, you can see that there is async keyword used to tell the compiler that within this function, I'm allowed to use the await. So that's the first thing. And the other thing is that there's an error on the right code because the return type is not void anymore. It's returning future void, because each time we are making an async function, its return type must be a future.generic. And what does it give us? What's the point of using the async and await? It simplifies the execution flow because we can treat our code like it's asynchronous. Like in this example, we have a try catch, like in the example from the Google Cloud Functions, where we are printing the start main, then we are awaiting for some future where we are printing something, then we are throwing an exception on line 7. On line 10, we are printing oops in case of any kind of error, and then we have an end main. And what's the prints on the console? As you can expect, that's a start main, future is now, oops, and end main. And what's cool with the async and await is that you can read your code from top to the bottom. There is no like then, and it would be executed when the event loop will handle my function, blah, blah, blah. Nothing like this. You can read your code from the top to the bottom using the async await. So that's a great thing. And the other is that you can simply try, catch, and catch all your errors. It doesn't matter if it's synchronous or it's asynchronous. You can catch this the same way using the try-catch block. And interesting part about, because we've been talking about the event loop and the event queue, but there is also a microtasks, as you can remember. So to be honest, I haven't used the microtasks in any of my product applications. I've been using the event queue to make the futures, to work with the streams, but the microtasks, yeah, that's a cool concept to have a high priority queue. But I haven't used this. But it doesn't change anything because I just want you to show you some interesting fact about the greedy microtasks. Because here we have some code. It looks quite simple. We are printing something. We are creating on line 10 some future. Then we are using the schedule microtask, which will put this callable on a microtask queue. Then we are calling the attention please, which also scheduling the microtask, which is calling the attention please, which will in turn schedule the microtask. So here we can see the infinite loop. And what's the execution of it? The first thing is that we are printing the start main, end main, because that's asynchronous. Yeah, that's okay. Then we are printing micro1, because that's the first scheduled microtask. After that, we are scheduling some microtask, which will run the attention please. It doesn't print anything, so that's okay. After that, we are scheduling microtask micro2, but what happens with the future is now. When would it be printed? Well, it won't be printed never, because in this infinite loop, we are scheduling the microtasks forever, infinitely. So the future won't have any chance to be executed by the event loop, because the event loop has enough microtasks to execute. So they're so greedy that they won't allow the future to be executed. You will probably don't need your code to use the microtasks, but it's a quite interesting concept if you need to run some code before giving control to the other events on your event loop. And what about the concurrency? Because we want to run some code in parallel. There is such concept. I won't go much into the details of it because the isolates deserves its own presentation. But the isolate is a Dart's version of thread. So if we have a multi-threading language which spawns threads, we have in Dart an isolate. And as the name suggests, we have no shared memory. Isolate is isolated. We don't have any shared memory between these two. We cannot access the memory of the isolates across each other, even if you are a parent of this isolate. It's worth to remember. The isolate have its own separate event loop. They are sending messages through ports, and they are parallel when possible. So when we have more cores on the CPU, they will be executed in parallel, but it's not guaranteed. And how does it work? How does it look like on a Dart way? In Dart way, the API is not pleasant to work with, to be honest. That's the simplest scenario where we are creating some receive port to communicate between isolates. In line 10, we are spawning the isolate. You can notice this await keyword. So does it mean that isolate spawn returns the future? Then we are listening on this port, and we are printing all the messages from the isolate, and that's it. Worth mentioning is the fact that this function, this entry point to the isolate spawn, needs to be a top-level function or a static function. It cannot be anything else. So you cannot provide here a callable other than top-level function or a static function on your class, for example. So that's a Dart way of isolates. And Flutter has its own way of dealing with the isolates. Because in mobile application, why would you even consider using the isolate? Because you have some heavy work to do and you don't want to block your UI thread. For example, we have this random sort algorithm to sort our list. It's quite heavy. It will block our UI for 5 seconds. So if we want to do this work without blocking the UI thread, we need to start some isolate. It will sort our array, and it will return the sorted list into our main thread. And how does it work is that Flutter exposes for us the compute function, which simply needs entry point and what argument do we want to pass. And that's it. It will simply perform all the work of spawning the isolate, killing it, clearing, garbage collecting, basically everything which needs to be done in order to keep the code clean. And simply just remember that the data which you are passing to the isolate needs to be a primitive. So you cannot pass an object. Well, you can pass the object because, for example, you can pass string or double or int or list with these primitives, but you cannot pass your own objects, like a user object or anything like this. In order to send such complex objects between two isolates, you need to serialize it on the main thread and deserialize it on the isolate. So that's the only solution to handle it. And to wrap it up, all the things is that single thread doesn't mean it's slow, because we have an event loop, we have an option to run async code without blocking the thread. We have the isolates, so a single thread is not a problem with Flutter applications. Keep in mind the event loop and the event queue, even if you don't need to think about this on a daily basis when you're working on your Flutter application. Keep in mind that it exists and how does it work. Use isolates for heavy computations to offload the main thread. So if you don't see any problems with the performance of your application, you don't have any heavy computations which will take more than 10 milliseconds to perform, then don't do this on the isolate, because probably it's not worth it. Switch your syntax to async await to mimic synchronous flow. So it would be easier for you to follow what is happening in your code rather than moving between the then, catch error when complete, and so on. Believe me, it's much easier to follow such code. And last but not least, do not use isolate in a Flutter driver. So Flutter driver is a thing to write automated tests in Flutter. And the thing is that isolates do not work with the Flutter driver. Yeah, I know. That's a bit strange, that there is an open issue with it, that the mobile application which is using a separate isolates do not work, because Flutter driver spawns the isolate and then immediately the isolate is paused. So you cannot provide any kind of isolates. So you have to provide at least some conditional checks that if I'm running the Flutter driver, don't use the isolates. That's the thing which we're doing in our mobile app as for now. We have a simple check to do not spawn isolate in a Flutter driver. And that's it. That's it as for the asynchronous way of Flutter. And that's just a beginning of your journey on how to discover, because there are much more concepts of async programming, like streams, value listenables, value notifiers, and so on, so on. So there is much more than this. That's just a beginning. And that's it. That's it from my side. And thank you very much. Let's see if there are any questions.
Thanks, Kamil. That was very informative talk. I learned a lot. We are waiting for questions. We have around 10 seconds delay in YouTube. So let's give the community a bit more. I saw there were few discussions on YouTube, but people answered each other, so maybe there won't be any question. But you can check yourself if you would like to add something. We have one comment.
Thank you very much.
So we have a question from Kamil. Nice talk. Can we get back to catch error example?
Oh yeah, sure.
Do you have any specific question to that example, Kamil?
Is it this one?
Okay, I see we have more questions, but wait for Kamil to ask what he would like to know from this example. And okay, maybe we'll come back to this question. We have, oh, there is. So
Right, so
Camille says, I didn't really get why catch error did not catch error in Google example.
oh, so we're talking about the example from the Google. So let me switch the slide, and let's look into this code. There is no catch error here. If you will see, we have call to the future, like call cloud function. That's a future. Then we are having some then. So we want to execute some code after the future is completed. But the thing is that this particular future could raise an exception. And this exception would not be handled by this try-catch block. And a Google developer or some community developer, basically, even I do same mistakes when I'm working with a catch error and the syntax like this without the async await. They missed the catch error here. So if they would implement the dot catch error and then they will handle the error of the future here, then that would be all right, but they missed it. So in order to fix this, we would need to put like 8 characters. Yeah. So we would need simply to put at the first line of this code the async word. And after the return, we would put await. So we would simply await for this execution, and then we'll catch an error in a standard try-catch block. Hope that answers your question.
I hope to. We have a question from Mulwadam. Can I use Flutter Async to develop downloader?
Well, it depends on what the downloader is. If that's some kind of application which downloads a file from the internet, like you're pasting some URL to a file, then you're clicking a button, download, and the file is downloaded, then sure, that's a typical scenario for using the asynchronous programming.
I saw one more, but this is answered by Dominic on chat. And we have from Robert, thanks, really good talk. When will you present on the future async topics?
Well, probably at the next GDG3City meetup dedicated for the Flutter. So subscribe and observe when will it happen.
Yep. Okay, I think that's it. Thank you very much, Camille. Great talk.
Thank you.
And now we'll have Marcin Kitowicz. Hello, Marcin. Are you ready?
Hi. Yes, I'm ready.
Great. Marcin will talk about GitHub Actions and Firebase app distribution. And his example will be the Flutter app. So we'll probably see how to make it with Android and iOS simple way by one in one environment, right?
Yeah, basically, the example will be in Android and web, but yeah.
Okay, Android and web. Sounds fun. Okay, Marcin, so the stream is yours. I'm going out.
Okay, so hi everyone. Today I will talk about how you automatize your deployments using GitHub Actions and Firebase app distribution. We will go through setup for workflows and steps to understand parts of GitHub Actions. Furthermore, we will create our own custom action, which will be used in our deployment. I am aware of the fact that this is a very broad topic and it will be difficult to say everything in one presentation. So I made a simple project where you can find all examples from this presentation. I hope after this talk, you will be able to configure your automatic release of your applications using GitHub Actions. If you will have any questions, I will try to answer them at the end of the talk. And yeah, my name is Marcin Kitowicz, and I have been working as an Android developer in Schibsted Tech Polska for about 4 years. And I am a Flutter enthusiast. but to be honest, I haven't made anything big in the Flutter so far. But I really like Flutter, especially how fast and easily you can make the UI and constructors. I saw some comments on YouTube about that. And I'm also a GDG3City member. I think I can call myself this way. I'm trying to support this group, and that's my second talk in this group. And to be honest, that's my first presentation in English, so please forgive me if I make any language mistakes. You can find me on the GitHub, where I keep my small projects and experiments. For purposes of this presentation, I made a simple application written in the Flutter with all deployment configuration, which will be discussed later in the talk. The app is really simple. It allows you listen to the online radio stations. This project supports 3 different platforms: Android, iOS, and web, in 2 different versions, test and production. You can check this out using this link or just browsing my GitHub account. So let's talk about the distribution model. In our project, we will be using an approach based on Git branches. It's quite similar to Git flow. In our repository, we will have 2 major branches, develop and master, and all code changes will be added by making pull requests. Let's go through the scenario with publishing and adding some changes. Let's imagine that we have some new functionality to implement or bug to fix. So we start with coding. And if we are done, we push our changes into some branch. Let's, for example, call it awesome feature. Next, we are creating a new pull request. And we have to wait till all checks will pass. In our case, we will be checking code style and running some tests. We will go through this integration in a moment. If everything goes well, we will merge our changes into the develop branch. And after that, another integration will trigger building and publishing our app into the Firebase app distribution. Or for the web app, it will upload code into the hosting server. Okay, so we know how our flow looks like. Probably for some of you, this isn't anything new, but believe me, there are still some companies where people are doing this task manually. And deployment into production will look similar. We have to create a release branch from the develop. Then we merge changes from release branch into the master. We could build another type of application in this step, some kind of pre-release version, but in our setup, we'll skip this. And after a while, we should be able to download new version from the market, or to be able to check new web app version in the browser. Okay. In our project, we will use these tools, of course, GitHub Actions, Firebase app distribution as a place for test apps, Firebase hosting as our web server, and Fastlane as a helper in app release processes. Okay, so what GitHub Actions are? Basically, that's another CI/CD tool which allows you to run your scripts or programs. It's similar to platforms like Circle CI or Travis, where you are able to run a virtual environment based on different operating systems. For example, you can choose Linux, Windows, or macOS. GitHub Actions offers you quite extended configuration based on workflows, steps, and actions. In my opinion, the biggest advantage is that if your repository is on GitHub, then it's already integrated with GitHub's actions. you don't have to use any other external services. It's quite handy that all your build logs are available just from your repository. There are on the special actions tab. Okay, so let's talk about the money. Another big advantage is that GitHub Actions are available for free in public repositories. But don't worry, if your repository is private, you have 2,000 minutes per month for free to run your workflows. And each virtual machine has 2-core CPU with 7 gigabytes of RAM. I would say that's quite nice limit even for bigger projects. Information about how much quota you have left can be found in the account settings on billing tab. GitHub Actions have actions in the name, so behind this is the idea of creating and sharing small scripts for your workflows. Basically, you can reuse them. All actions are available on the marketplace. They are open source and free to use. We will create our own GitHub Actions a little bit later. That's enough theory. Let's get on with the practice. Now we are gonna create our first flow, which will be run on every pull request. And like I said before, it will check code style and run some tests. In the beginning, we have to create additional directories in our project. The most important directory is called .github, and we have to create subdirectory workflows inside. There will be storing all of our configuration. Workflows have to be written in YAML format. We can use any name of workflow files, but I like to use names corresponding to branches. We start our configuration with the workflow name and information about when it should trigger. In our case, it's a pull request on develop branch. Each workflow contains one or more jobs. In our example, we have 2 jobs, one for checking code styles, in our case called lint, and another one for running tests. We can run jobs one after another or at the same time. If one job requires another, then we have to add the needs command. But in our flow, we can run jobs at the same time. They are totally independent. Every job should have a name and information about the runtime environment. We have to, in our case, we use the latest Ubuntu version. But for building an iOS app, it's required to have a macOS value here. So keep this in mind. Next, we have to define steps for our job. We can have many of them. We can use actions made by someone else available on the marketplace on run bash commands. In our case, our first step will be checkout action, which will pull our source code. The second step in our case will be, let's say, download and install all the required software. But in this example, I just want to show you that some actions will require additional parameters. We can pass them in this way with basically a directive with. Here we are passing information about the Flutter channel. We want to use a beta version because beta versions are the best on the productions. So, yep. The next step is just executing a simple bash command which downloads project dependencies. It's just a standard Flutter pub get. And finally, we run our lint action, which just executes Dart analyzer with some sets of rules. But I want to show you that some action may require a presence of specific environment variables. We can pass them using the env sections. Like on this example, we are passing GitHub token to this lint action. This token is necessary to be able to add annotation in pull request in cases of error or warnings. The final effect on our lint job is the output like this. If some code changes are against our style rules, then in our pull request, we will see annotation to specific lines with message what's wrong. It's really useful because it looks like that someone made some kind of code review in our pull request, and we can just check it in our current pull request and fix them and commit and push changes again. In the similar way, we defined our second job, which is run tests. I let myself skip the first steps, like check out the code, install required software, and stuff like that, to show you only that we call 2 commands and the end of our job to execute test in the project. So basically, that's our first integration trigger on pull requests with merge to the develop. Let's go to some another topic. As far as I remember, testing CI or CD configuration is always a challenge. Pushing changes every time when we want to test some flow isn't fast and nice. In our case, we can use software called act to run GitHub actions locally. We can test it locally before we push our configuration to the remote repository. This software tries to mimic the GitHub cloud environment, and it uses Docker underneath, so we need to install Docker first if we don't have it. I'm not sure if you can see it, but this is supposed to be a GIF with a demo of running GitHub actions locally. I execute the act program with pull request parameter. So basically, it tries to find our matching workflow and execute all things on our machine. So as you can see, it tries to download some kind of software and finally execute linter and our tests. So we can configure the act in some way. The most important are for example, the first line sets the system image. I mean, this is a Docker image, what we want to use. Unfortunately, image with all installed software, like on the GitHub Action Cloud environment, is super heavy. It's something about 20 or maybe 25 gigs. So I would recommend using smaller images that fits our needs. I choose something smaller in my case. That's a Docker image with pre-installed Android SDK, because that fits my needs. And the second line is also important because it points to the file with our secrets, what will be used during our deployment. For example, Firebase token, Android KStore and stuff like this. Of course, we shouldn't add this .env file into our repository. We can easily ignore this file, adding a rule in git ignore. But all our project keys, password, and other sensitive data should be stored on the secrets page. It's available from repository settings. And if we want to test GitHub Actions locally, we should have the same data in our .env file for this act. Okay. The biggest advantage of GitHub Action is that you can make your own actions and share it with others. Let's create simple action, which will be used in our release workflow. So before we start, it's worth to mention that there are two action types that we can create. The first one is based on the Docker container, which give us full freedom because we can prepare images with all required and installed software there. The second type is just a script written in JavaScript. We are gonna use this type of action because JavaScript is, the best language. The source code of our action can be placed in our repository, so we can run our action from the code we hosted. Then we can use it by providing a relative path to it during defining our steps. We start creating our action from a file with metadata. It has to be named action.yml and contains some information. The first are name and description. For our needs, we will create a simple action that encodes base 64 values from secrets and save it into a file. We are gonna use it to restore sensitive files like keystore or some JSONs during the build. We have to do it because this repository is a public repository, and we can't just add such files into it. So we have to use some kind of workaround. In our case, we are gonna need two input parameters, the encoded value and destination file path. Next, we set the running environment to Node.js and point the main file to index.js. The last one is branding. It allows us to select some fancy icon and color. If we decide to publish this action, it will look like this on the marketplace. So you can see this fancy icon with fancy color. So yeah, this is the branding. And if we have all of this, we can start writing the code. So GitHub gives us some sets of libraries to help with creating actions. We will use one of them called Actions Core. Thanks to this library, for example, because this is not all of the responsibility of this library, we can easily read past parameters. In our case, encoded value from secrets and destination file where we want to save our decoded value. And use them in our super advanced encoding and creating file implementation algorithm. This is just those two lines, so yeah. And this is how we can call our action in our job. Just specify the relative path to directory and pass, mentioned before, these two parameters. Okay, so Finally, we know how to set up workflow for testing and checking code styles on pull requests. We also know how to write and use custom action, so we can go to the workflow which release our Android application, Android test application. So let's get started. All configuration will be placed in develop.yml file, as you can see at the top of this snippet. It will be executed after a push on the develop branch, in our case, when we merge pull request. Our job will be called build release test Android and will be run on Ubuntu. Mobile application must be versioned correctly to be recognized by the market or Firebase app distribution. We need two types of versions. The first one is user-friendly text, for example, 1.2.3. In this example, we will read this value from the file placed in our repository. Of course, there are many other ways to do that. For example, we could use git tag or use release branch name. But in my opinion, this is the most straightforward way. Just read it from the file. Sometimes you have to do some hot fixes and stuff like this in the current release, and you can use the same version for the user. Second type of version is something called version code on Android. It's something similar on iOS. In this case, we are gonna use the build number from GitHub. This is the value which is increased on every run. And in this step, we're just printing these values. Of course, like in the previous example with our pull request integration, we need to get all required software to run our build and deployment. So we are doing it in this way. And next step is to restore all secrets and necessary files to sign the APK. We will use here created previously our custom action. So for example, we restore here a file called Google Services and a key store to correctly sign our application. Finally, we can start building our application. We called Flutter build APK with previously mentioned versions. If we decide to use flavors to distinguish apps between test and production, we have to pass additional parameter here. But we have to be careful with the flavor names because they are in some way case sensitive. I mean, when we use uppercase letters in our flavor, the build script will change them into lowercase and use such value for output APK name. But after this, we'll still be looking for mixed case original name, and it causes the error during the build. I'm not sure what's wrong with this, but I had to change the flavor name to completely lowercase to skip this issue. But anyway, the last step is just run the Fastlane with specific line. If you don't know what the Fastlane is, that's basically a tool which helps us uploading app into the market or Firebase app distribution. It also helps with signing iOS app. I'm quite familiar with this tool, so I choose it to use also in this project. So our Fastlane will, in this case, run only one command, and it's worth to pass, for example, last commit message as a release notes to get in the test app from Firebase to know what changed and to get some news for our testers. And yeah, that's it. I hope this information turned out to be useful for you. I'm aware that this topic is very broad and it's difficult to say everything on just one presentation. However, I hope I encourage you to try GitHub Actions if you haven't used them yet. Everything that was shown in the presentation, or even more, is available in example project on my GitHub account. If you have any questions, I will try to answer them now. So,
thanks, Marcin. That was a huge topic.
yeah.
I will need to probably play it once again on YouTube to apply it to my project. But that's great. I think YouTube Actions is the thing. Everything in one place, your repo and the actions. We have some questions. First one is from Dennis. Could you post your final YAML file somewhere?
Yeah, it's available on my...
It is on your repository, right?
Yeah, that's available on my public repository, which I mentioned at the start. And basically, it's available on this link, or just when you browse my GitHub account. So, yep. There is.
I just posted your GitHub account on YouTube chat. So any question like that, you can check in the repository. Another one is, are these instructions blogged somewhere, step by steps?
Yes, you can check them using the README in this repository. I know that still some space for some explanation in README in this project, but yeah, you can just use them as your starting point. So yeah, basically that's my proof of concept that you can deploy your Flutter application for different platforms. So yeah.
Okay, we have one not related to actions, but interesting one.
Yeah.
Can you tell us what packages do you use to develop online radio app?
Yeah, that's a very interesting story, because I started my journey with Flutter with some open source library and try to use in this example. And this is, I don't remember the exact name of this library. You can check this in this project dependencies, but of course, there are still some issues when you are trying to use open source library in your specific case. And I really love this, because if you can help them in develop such as library, you automatically help yourself during your project. So yeah, I recommend check this dependencies, check dependencies for this project using this GitHub repository.
All right, the last one from our previous speaker, Kamil. What's the worst part of GitHub Actions? There must be some.
I would say if you are heavy GitHub user, you have everything in one place. That's a huge advantage about this. And also, even if you are hosting private repositories, GitHub gives you something about 2,000 minutes to run your integration scripts, and the virtual environment has 7 gigabytes of RAM. It's quite huge value if you, for example, compare it to the Circle CI free plan, which gives you only 4 gigabytes. And for bigger projects, I think it's a quite huge value, especially if you are building Android projects with Java and Gradle.
Marcin, if I understand you correctly, you are talking about good things about GitHub Actions. The question was about the worst part of GitHub Actions.
Okay, sorry. So for me, the worst stuff was about you basically can't reuse your steps between different workflows. So you have to copy and paste common steps between, for example, deploying your production and test application. So that's the worst part for me.
Okay. One small question from me. If I would like to start and I have zero knowledge about GitHub Actions, could you estimate for small project how long it will take for me to learn to deploy Android app, for example? Is it a few hours or a few days? What do you think?
From zero to hero, I would say it's something about 2 hours to set up basic workflow and publish your app on, I mean, Android app, because I am the Android.
Yeah, me too. The question is about Android.
Yeah, so I would say 2 hours to set up deployment for Firebase app distribution, or even for Google Play. Yeah.
Okay, that's great.
Yeah.
Sounds good. Thank you very much.
Thank you.
Yep. So let me turn this off, and Dominic is waiting. And here we go.
Waiting.
Hello, Dominic.
Hi. Good to be here. Thanks for hosting me. Let me know if
no problem.
Hear me.
Yeah, we hear you. We have a little bit of delay.
Yeah, of course. So good to be here. I'm happy that you are all here in the audience. We're going to have some introduction to custom painters today in Flutter, and after that, some fun. Yes, this is my presentation. So actually, my presentation will be our playground today. So let's start with the introduction, the very basic step that we have in all presentations. So I'm Dominic. I've been working with Flutter for over 2 years now. Before that, I was working with Xamarin, with .NET on the backends. I am co-founder of Flutter Warsaw Meetup and Flutter Europe Conference that took place in January in Warsaw. And I sometimes write some articles on my blog, roszkowski.dev. Feel free to check out. And I post some UI challenges and Flutter tips and tricks on my Twitter if you are more into this kind of social media. So I kindly invite you to follow me. Painting in Flutter. So I read in the chat that there are several people that have just started with Flutter and don't know a lot about it. So just a quick recap about Flutter and how to actually do the UI in Flutter. So usually you would use widgets, which are like the basic building blocks of a UI in Flutter. These widgets can be composed, can be used to create some complex widgets. So for instance, you could use decorated box, sized box, containers, row, columns, texts, and many, many more widgets to build your UI. But sometimes these are not enough. Sometimes you need to create something more custom, more complex, something that is not actually possible to build with typical widgets. And in these cases, you can use custom paint. And custom paint is also a widget actually in Flutter that is using painters. So let me go to the code to show you how to actually use this. So as I told you, this is actually this is actually a Flutter application that is running here. Let me know if you can read everything clearly. So this is the source code that we'll be working with. And here's the app that we will be having fun. There will be more to show later, but if you have some problems with text visibility, please let me know and I will check on the chat if everything's clear. So here's my page, and as you can see, here is the title, painting in Flutter, and here is my widget called Custom Paint. So if you want to paint something in Flutter, you have to use a Custom Paint widget. If you take a look at the source code of this, you will see that this has several interesting properties. So Custom Paint accepts Painter, which is a custom painter class, foreground painter, size, flag called isComplex, and flag called will change. You can dig deeply here to see what actually each property means. But today we're going to focus on painter and maybe later foreground painter. So painter is a custom painter. So here's my painter that I created called basic painter. And also custom paint has property child. So very important thing with using custom paint in Flutter is that it will size itself to the child. So for instance, if I would have here only, or I wouldn't have a child here. So let me just comment this out. If I wouldn't have a child, then this custom paint would have size 0. Yep, it wouldn't have actually any size. But if I place my child below this, inside the custom paint, then my custom paint will have this size. So let us go now to this basic painter. So basic painter is my custom painter, which is a class that is used for painting. So if you want to create your own custom painter, you just create new class. So let's create new painter that extends custom painter. And actually, that's all that you need to do now. Now you just need to create missing overrides. And here you will have two methods in your custom painter implementation. One will be called should repaint, and the second will be called paint. So let's focus on the second one for now. So should repaint tells Flutter if this painter should be redrawn, repainted on a new frame. So usually, if you have a static painting that doesn't change with frames, you can return false. Of course, the paint will be repainted if you set state or something like this. So the widget tree will be rebuilt. But this is also important if you do some kind of animations with custom painters. So usually you want to then return true to repaint your custom painter on each frame. You also may have noticed that here custom paint had flag called isComplex. So if you set this flag to true, then Flutter will try to cache some parts of the painter, not actually parts, but some things in the painter to improve performance. But in our case, we will have very simple paints, so we won't have to cache. So here's my basic painter. and I have my method called paint here. So here I have my canvas and size. So if I would like to check what actually is in my what is the size of my paint. So here below is my debug console. So as you can see, maybe not, the size is 300 by 155. So this is the size of my canvas. Of course, I don't need to check this every time. I can just continue with my painting. So in order to paint anything on this canvas in Flutter, you need to have at least two things to use on a canvas. The first one will be paint. So paint is an object. It's a mutable object that will be used to paint your something on a canvas. So here we have a paint that has color red. We'll use style of stroke. So there are two possible styles of paint. So one is fill, the second one is stroke. Fill means that all the whole object painted with this paint will be using this paint. If it's stroke, then only edges of this object, or in case of path, only the path. In case of circle, only the edges of a circle. Also, you can define stroke width and many more properties that we're going to go through today. Then the second thing that you need is the object that you want to paint. So right now, let us use path. And path is another very interesting tool to use in Flutter. So here I am just using quadratic paths to draw something, but you can also use some other methods on path to create some paths. So for instance, you can just move around your path. You can add arcs, you can add lines, rectangles, and many, many more. One important thing is that path can be drawn. For instance, if you draw a line, you can draw the line to absolute coordinates, but also relative to the point that you're actually in. So important thing is that if you just create your path, it will start at the point 0, 0. So point 0, 0 is right here. But you can also move around your path. So as you can see, this is my path. These are 4 quadratic Bezier curves. And if I just move my path, let's say to point 10, 100, so you can see my path is now moved from the point that it started. I can also change my call to relative instead of absolute. So as you can see, my path is being changed on the screen. Also, you can paint some other things on your canvas. So for instance, here I just painted a rectangle. So in order to do that, you just use canvas draw rectangle. And this is, again, as I shown you, the paint object is mutable, so you can reuse it. So for instance, here I created this paint, and then I just modified its properties. So now it's using green color and different painting style. Important thing to notice is that all the actions in the custom paint are executed in order of appearance. So if I move my path after the rectangle, it will use this paint and will be drawn after the rectangle. So let us continue with the flow. You can also draw some other objects, some other shapes. So here I created a circle and I used mask filter on this circle. So I changed the color to yellow and I applied blur mask filter with normal style. I can use some other styles. So for instance, I can just blur the outer edges of the circle. I can blur inner edges. And also I can define how much I want to have this blur applied. Yeah, slide is my custom widget that I created. I can show you later how it looks like. It just adds the footer and header for purposes of this presentation. This is just a stack. I can also create some other interesting shapes. So for instance, if you want to, for instance, create a plot, you can use points to to draw them on canvas. So here I create my new paint. I modify my paint to use orange color. I disable the mask filter. I change the stroke width, and I use the stroke cap round. So here you can see that this will finish all paths with a round end. I create some random, semi-random points. So what I do, I'm using the for clause in collection to just populate this with 50 points, and I just create points spread equally every 15 units, and that draw a sine wave. And here I just draw my points. I can change the point mode to lines, so all the points will be rejoined, reconnected, and I can also use polygon, and now all the points are connected. In case of lines, the lines are drawn every 2 points. And I can also draw some more complex shapes. So here I have lines relative to the point 90, 50. And interesting part here is that I'm using blend mode. So in many graphical applications, you have these blend modes. So here I'm using color burn, but I can also use some different, like source over, or I can use multiply to have some different effects. So this was like quick overview, but of course you can draw many, many more things on your canvas. So for instance, paths, circles, lines, images, arcs. You can clip your paths. You can draw ovals, colors, pictures, points, and many more. But we could spend hours on that. So let us continue and see something that is very useful. And if you create custom paints, you may have to use this. So here we have a custom paint that is used that just draws an image. And let me show you how to actually draw an image. So here's my image painting widget. So this is actually the whole page is image painting. This is a stateful widget. Bear in mind that this is a stateful. For those that do not know what is what are stateful widgets, these are the widgets that allow us to keep something, keep some kind of state with them. So here I'm keeping an image, reference to an image that is drawn here. And what stateful widget allows is that I can call one function at the beginning at the creation of the widget called initState. And in this function, I just load the image from my assets. And here's my helper function that I have called load UI image from my asset. You can check out later in the source code or on Stack Overflow. This is taken from Stack Overflow, how to load an image to the UI image class. And later, again, I have just my slide with my custom paint. So again, slide is just my stateless widget that allows me to host my footer and everything else. And here, again, I have my custom paint and my image painter where I provide my image because I need to load it somehow. And this is my container that spreads across this widget. Again, we can check what happens if I remove my child. As you can see, now my painter is positioned at the top of the screen, and I don't want this. So let us again return with the custom paint. Let's take a look at our custom painter. So here we have some comments. We will get to them soon. So here I have my if the image is not null, I draw my image at some offset with some paint. Actually, if you draw your image, it doesn't matter what kind of paint you use. Of course, if you, for instance, want to add some filter, it's relatively easy. Oh, actually, I have this below. Yeah, so If you want to, for instance, blur your image, you can use the image filter. So here you can see if I applied image filter to my paint, now my image is blurred. But let's come back to the previous state. So when you have your canvas, you can make some operations on it. So for instance, you can rotate your canvas. It accepts radians. So here my canvas is rotated by 0.2 radians. And of course, you can imagine a situation where you change this value and have some kind of animation going on. And here I wanted to show you something that allows to make some more complex transformations on your widget. So Canvas has also this very useful method called save and restore. So what it allows us to do is to separate some processes from happening, like isolate them. For instance, if you want to apply some more complex transformations to your objects, what it provides is that all the operations are placed on a stack right now and will be performed only after the restore. So for instance, here actually not much happens, but below that I have a much more complex example. So here what happens is that, let me just not rotate this, not clip my image. Okay, so here I have, and not translate. So you see, something's changed when I applied Canvas Save and Canvas Restore. So here's actually a good example of this. So at this moment, I save all the operations that happens on Canvas to the stack, on the stack. Then I clip my canvas with a rounded rectangle of some size. So this is the first one. Then I draw only white color across the canvas. So all the canvas is being filled with paint of color white. So if I wouldn't clip my canvas here, the whole canvas would be drawn with white paint. But actually, I clipped my canvas, and only this part is drawn with white paint. Then I restore my canvas, and I can see that this part is filled with white. Then the same thing happens, but on the bottom right part. If I wouldn't save and restore my paint, then all the operations that happen after this rect wouldn't be visible, yeah, because this paint and this clip happen here on the bottom right corner of the canvas. So if I restore and save again my canvas, I can combine some more complex operations, or in this case, actually separate them to be able, for instance, to operate on different parts of my canvas. So this is very useful. There is another method called Canvas Save Layer that is a bit more complex, that allows you to only save a selected part of canvas. So this is much more memory expensive, but sometimes you might also need this. And just like for the end of my presentations, I wanted to show you something that should inspire you to create something with custom paint. So actually, this is a game in Flutter. This is a very famous Chrome T-Rex game. So this was created only with custom painters. So let me show you how to actually implement something like that. So here's my game slide, of course. Here I'm just using stack, footer, and in the center I have my game page. My game page is this stateful widget that has a class called T-Rex game. This is just a controller to run the animation. And I'm initializing this here. This, of course, is much more complex to describe in a few minutes. But if we go down here, we can see that I have my custom paint actually here, and I have my T-Rex painter, which is again my custom painter. At some point, you just create custom painters like automatically. So here I create some paints in my custom painter. So one is using gray color, another is using different shade of gray and have different styles and everything. Here's my method paint. You know very well that here's all the logic behind painting happening. So for instance, I draw my horizon. Sorry. Yeah, so if I comment this out, I don't see my horizon anymore. I draw my obstacles. Yeah, so this is a very handy way to separate some parts of the canvas. So if you go to the horizon, you can see that I save my canvas here, I translate this, and I draw some other parts. The same happens, for instance, here. If I draw my obstacles, I save my canvas, draw some things, I save this again for each of the obstacles. Yeah, so I have my obstacles, and each of them needs to be translated to a given point. This point changes with each frame, yeah, because with each frame, this position property of the obstacle is changing, and so on. And also, I have a custom painter for the T-Rex itself. So my T-Rex is painted with paths. So if we go to my draw T-Rex method, you will see that I just get the properties of T-Rex here. And this is actually just a list of points, in this case, list of offsets that represent the T-Rex. And I also can draw a dash. So this is a like custom painted dash. So if you take a look here, draw dash, and here get dash. So that dash was actually painted with like paths, ovals, arcs, and so on. So you can actually create many complex things in Flutter with custom painters. So this will be everything for today because I had only like 20 minutes to present. But if you have some questions, I'm here to answer them. So this presentation is actually available. Let me just share you the link. So this is called custom painter presentation on CodeMagic. I will just post the link to the YouTube chat. So you can open this and have some fun for yourself. And if you also want to see more of some kind of UA challenges, recently Flutter announced that CodePen supports Flutter. So there is also my account. You can type Orestes Gaolin to see some of my creations. So for instance, I created Space Simulator. If you're into that, you can check out this or some other things like animated logos, Netflix, Flutter, Slack. Are there any questions?
I have one question. Do we have time, Dominic? You said you need to go.
I need to run in a few minutes, but my colleague can wait.
What language is used to create the game? I think Dart.
Dart. So this game is in pure Dart with use of custom painters. This is available on the CodePen, so you can check out on the CodePen the full source code. So this is open source. This is very simple. Like, of course, there's a lot of code because this is all in one file. But here is my change notifier that is used to drive the game. I'm not using any packages. This is in pure Dart.
Did you code that alone, like, or you used some? I don't know. For example, T-Rex is somewhere copied from internet. So
T-Rex is actually like I took SVG of T-Rex from the Chromium source code. Yeah, so we can take the source code of Chromium to see what kind of SVG is used there, and I just redraw this in.
Okay. But you code all of this by yourself, all those offsets and all the paths, everything.
Yeah, I took the SVG, copied the the coordinates of points, used some kind of find and replace, and this helped me to create this in relatively short amount of time.
Very interesting question from a user I can't really spell. When we create an Android animation custom view, it is advised to avoid using paths, paints, and any object on draw method. Would you say it is the same here for paint?
So yeah, my presentation was highly unoptimized. Yeah, so usually you don't want to create many new objects in your paint method. But of course, it highly depends on what kind of animations, what kind of drawing you create. So in case of game, when you have a lot of changing objects, you need to spawn them very frequently. I would advise to maybe separate this, extract this, abstract this from the custom painter. In our case, where we had these very simple things, like here or here, they are actually not so expensive, so we can create them in your paint method without any issues. Of course, in more complex situations, you would like to maybe create them not on each paint, but maybe store them outside the custom painter.
Okay. Any more presentation? Any more question to the presentation I wanted to ask? I see none. Thank you, Dominic. Great talk. Applause. Really impressive that this amount of code and that you actually did a live demo for us.
Yeah, I'm not often.
That is always a big risk.
Yes. Thanks a lot. I hope you had fun as I did. So see you on the next one.
Thanks. Bye-bye. Okay, guys. So now we have our final point in agenda, which is Kahoot. And I will try to share the screen with you with the Kahoot. Yeah, I succeeded. So here it is. Present, I think. Classic. Okay, you can join. Do you hear the music? Please go to kahoot.it and type the game pin. We have 15 person right now live, so I assume we'll have 15 players. Seven players, half of the audience. We'll have 10 questions, each related to presentations that we have today. And only one answer is correct out of 4. And the best player win gift, the card gift for Amazon. Okay, only 7 players. I don't know why not more, but I will give you like 10 more seconds and we will start. And 5, 4, 3, 2, 1. Let's go. So the first question. How to run parallel code in Dart using isolate, thread, protein, or isolator. Only one answer is correct. First answer, second. Still 2 to go. And I think we have all 7 answers. All right, isolate. 7% knew the answer and 2 were wrong. Zbój was the first. Good job. Second question, top priority queue in event loop is task queue, event queue, microtask queue, or mini task queue. Top priority queue in event loop. That's a tricky one. Okay, majority, let's say, 4% or half of the audience, almost half of the audience knew the answer is microtask queue. And what is the scoreboard? Is good one is the first in the list. All right, and then Piotrek and Szymon. Third question, how do the isolates shared memory with pointers, file holders, handlers, global variables, or none of the above? Pointers, file handlers, global variables, on none of the above. I'm super curious if you know. Did you listen? None of the above. Congratulations. Again, 4 persons. And how is the scoreboard? Piotrek is first. And good one is the second one now. Let's see, fourth question. What is the free monthly quota for GitHub Actions? 2,000 minutes, 1,500, or 1,000, or 3,600. Or as they say, 2,000, 1,500, 1000s, or 3,600s. Congratulations! 2,000. 8% knew the answer. Only 1 was not listening to the presentation. And good ones, again, first on the list. Congratulations. We will see how it will go. We have still six questions. What is the main directory name for GitHub Actions configuration? .actions, .github, config, or integration? Do you know? Ooh, it's half by half. Actions or GitHub? Actually, it's GitHub. And I think 1 person is sleeping. We had 9 players, but I see we have only 8 answers. All right. Good one. Still the first. How much RAM memory has GitHub Actions virtual machine? That's the easy one. 4 gigabytes, 2 gigabytes, 7 gigabytes, or 8 gigabytes? I think everyone knows, right? 7 answers so far. We are waiting for 2 more, but 1 person is sleeping. So 8 answers. So we are ready to go. Okay, only half of you knew the answer is 7 gigabytes. And oh, we have 1 leader, and more than 1,000 points in behind is Piotrek. Keep going. That is the format for GitHub Actions configuration files: XML, YAML, JSON, or JS. Yep, 8 person knew the answer. Great. That was easy, I guess. And the leader is only 1, and he or she increase the gap to the second place is almost 2,000 points. Next question, what widget is used to paint in Flutter? Custom Painter, Custom Paint, Canvas, or Canvas Paint? That's a tough one. Everything is possible. Custom Painter, Custom Paint, Canvas, or Canvas Paint? A lot of paint. Yeah, it's 5 person knew the answer is Custom Paint. I thought it's Canvas. I need to look to the presentation once again. Okay, we have 1 leader, but still 2 questions. So can we do something about it? What are the basic elements of layout in Flutter? Widgets, components, blocks, or tiles? Still 1 answer. Yep. Widgets, of course. Everything in Flutter is a widget. Oh, and we have a change on the second position. Borsuk came out of nowhere. Next question. What may be used to manage animations in Flutter? A material app, animation controller, animation manager, or stateless widget? What may be used to manage animations in Flutter? Animation controller. 4 person knew the answer. And what is the final result? Do we have any change on the scoreboard? 3rd place. Piotrek, congratulations. 2nd, Borsuk. And the 1st, we all know. Good one. Congratulations. Please reach me out on our Discord channel. You won the gift card for Amazon, sponsored by our partner Shipstead Tech Polska. Congratulations. Yeah, I'll leave it. Thank you very much for your attendance today. Thank you, audience, for a lot of questions, and thanks, speakers, for great talks. I learned a lot, and I think our community learned a lot as well. I encourage you to join our Discord channel. I will put the info on YouTube, but I also put it somewhere in the comments if you would like to check it. And I hope see you next time. We will have the vacation period now, so probably we'll try to do something in August or September. But if any of you would like to share your knowledge or knows someone that would like to share the knowledge with us, please reach me out or Natalia on LinkedIn or our Discord channel or anywhere you would like. And we can do event soon, as you like, whenever the presentations will be ready and the speakers. So any ideas that you have, please reach me out or Natalia, as I said. And thank you for attendance today. Have a good night. Bye.